set of results, which is really papers along with summaries and the archive links and stuff like that that you can jump to and you can read in detail. But what the value here is the ability to actually get an answer right out of the gate, and then also to get the paper reference answers as well. That way you can do the fact checking on your own. You can then even learn everything that researchers have learned and published over the last 4 years or 5 years. And some of this is really important because in these obscure areas where we're filling in expert knowledge, and maybe it deals with multi-specialty and stuff like that, you often have like teams that are doing some sort of study. And when that happens, effectively they cover dimensions that you normally wouldn't be able to read. But yeah, so with that, I'm just going to play with a few of these and kind of go through them one by one. Thank you.
The role of common model of cognition in designing adaptive coaching interactions for health behavior change.
So this section here has the main response output, which is going to be your comprehensive answer plus a read aloud of everything that's within that field. And that's about a 35-minute audio covering 20 different research paper insights in the overall answer. I feel like as like a lecture, if you want the lecture to come from almost the body of knowledge of scholarly researchers, this is the way to do it. Plus, since these are audio files, you can grab a copy and just save it locally. These are being saved as MP3 files. It's about 12 megs per 35 minutes, I would say. Yeah, so there we go, 12.3 megabytes, and it's done. So I downloaded. The next and so these are base64 encoded links of the MP3 files. And the read aloud, it allows you to pick a voice. So you can actually select from any number of the voices, which are over here. And then when it gets down past where it's rendered all of the MP3s and auto-save the file names. So the file names are kind of novel too, because it's basically the compressed important information from both the title and the summary of these papers. So these titles themselves, if you were to model, say, a tree of the vocabulary, this effectively could be, say, a network data set or a graph that really represents the state of the art of all the knowledge terms around this. And then you also get a research paper overview. And so for the research paper overviews, there's a marquee you can see. It's just kind of scrolling the title of the paper. Just a little bit of information about the paper, just a quick glimpse. If you did a screenshot of that, that would contain like the authors and stuff like that, so authors are attributed. And you can also then, for any given paper, let's say exploring the role of common model of cognition, you can then troll through the paper audio like this. And so you can set your playback speed. So I like to listen at 1.5. And hit it.
Exploring the role of common model of cognition in designing adaptive coaching interactions for health behavior change by Shirwali Mohan. Our research aims to develop intelligent collaborative agents that are human aware, they can model, learn, and reason about their human partners' physiological, cognitive, and affective states. In this paper, we study how adaptive coaching interactions can be designed to help people develop sustainable healthy behaviors.
And I'm not going to read through them completely, but I'll just give you a little bit of a sample. And so this was kind of like a paper overview, so you can take your time with this. And it really kind of gives you insights too, so that if you find a paper that actually covered some of the ideas that you really liked, then you can take that and feed that back into the system, creating a flywheel. Okay. So here's one that's going to talk about CBT, or cognitive behavioral therapy. And I've got some practitioner's guides on this with a background in psychology, but I've always been interested in seeing what the state of the art is, because back when I went to college, like human memory and stuff like that, they've rewritten all the books on it. So what we now know about neurobiology and memory and stuff like that, it's light years ahead of what it was when I went to school. And so I'm always interested in hearing the latest theories on it, because as AI evolves, I'm finding that also the neuroscience and neurobiology evolves along with it, because we're co-understanding ourselves at the same time that we're trying to design intelligent systems.
Local dynamic mode of cognitive behavioral therapy by Victor Argilov, Tori A. Creed, David C. Atkins, Srikanth Narayanan. In order to increase mental health equity among the most vulnerable and marginalized communities, it is important to increase access to high-quality therapists. One facet of addressing these needs is to provide timely feedback to clinicians as they interact with their clients, in a way that is also contextualized to specific clients and interactions they have had. Dynamical systems provide a framework through which to analyze interactions. The present work applies these methods to the domain of automated psychotherapist evaluation for cognitive behavioral therapy, CBT. Our methods extract local dynamic modes from short windows of conversation and learns to correlate the observed dynamics to CBT competence. The results demonstrate the value of this paradigm and outlines the way in which these methods can be used to study and improve therapeutic strategies. Understanding the information needs and practices of human supporters of an online mental health intervention to inform machine learning applications, by Anya Thiem. In the context of digital therapy interventions, such as Internet-Delivered Cognitive Behavioral Therapy, ICBT, for the treatment of depression and anxiety, extensive research has shown how the involvement of a human supporter or coach, who assists the person undergoing treatment, improves user engagement in therapy and leads to more effective health outcomes than unsupported interventions. Seeking to maximize the effects and outcomes of this human support, the research investigates how new opportunities provided through recent advances in the field of AI and machine learning, ML, can contribute useful data insights to effectively support the work practices of ICBT supporters. This paper reports detailed findings of an interview study with 15 ICBT supporters that deepens understanding of their existing work practices and information needs with the aim to meaningfully inform the development of useful, implementable ML applications, particularly in the context of ICBT treatment for depression and anxiety. The analysis contributes, 1. A set of 6 themes that summarize the strategies and challenges that ICBT supporters encounter in providing effective, personalized feedback to their mental health clients, and in response to these learnings, 2. Presents for each theme concrete opportunities for how methods of ML could help support and address identified challenges and information needs. It closes with reflections on potential social, emotional, and pragmatic implications of introducing new machine-generated data insights within supporter-led client review practices. Cognitive models as simulators. The case of moral decision-making, by Artavan S. Inobandigani, Thomas R. Schultz, Irina Risch. To achieve desirable performance, current AI systems often require huge amounts of training data. This is especially problematic in domains where collecting data is both expensive and time-consuming, e.g., where AI systems require having numerous interactions with humans, collecting feedback from them. In this work, we substantiate the idea of $\textit, cognitive models as simulators, which is to have AI systems interact with, and collect feedback from, cognitive models instead of humans, thereby making their training process both less costly and faster. Here, we leverage this idea in the context of moral decision-making, by having reinforcement learning, RL, agents learn about fairness through interacting with a cognitive model of the ultimatum game, UG, a canonical task in behavioral and brain sciences for studying fairness. Interestingly, these RL agents learn to rationally adapt their behavior depending on the emotional state of their simulated UG responder. Our work suggests that using cognitive models as simulators of humans is an effective approach for training AI systems, presenting an important way for computational cognitive science to make contributions to AI. Employing socially interactive agents for robotic neurorehabilitation training, by Rhythm Aurora, Matteo Lavit-Nicora, Pooja Prajad, Daniele Panzeri, Elizabeth Ender_E, Patrick Gebhard, Matteo Melosio. In today's world, many patients with cognitive impairments and motor dysfunction seek the attention of experts to perform specific conventional therapies to improve their situation. However, due to a lack of neurorehabilitation professionals, patients suffer from severe effects that worsen their condition. In this paper, we present a technological approach for a novel robotic neurorehabilitation training system. It relies on a combination of a rehabilitation device, signal classification methods, supervised machine learning models for training adaptation, training exercises, and socially interactive agents as a user interface. Together with a professional, the system can be trained towards the patient's specific needs. Furthermore, after a training phase, patients are enabled to train independently at home without the assistance of a physical therapist with a socially interactive agent in the role of a coaching assistant. Thought cloning, learning to think while acting by imitating human thinking, by Shangran Hu and Jeff Clune. Language is often considered a key aspect of human thinking, providing us with exceptional abilities to generalize, explore, plan, replan, and adapt to new situations. However, reinforcement learning, RL, agents are far from human-level performance in any of these abilities. We hypothesize one reason for such cognitive deficiencies is that they lack the benefits of thinking in language and that we can improve AI agents by training them to think like humans do. We introduce a novel imitation learning framework, thought cloning, where the idea is to not just clone the behaviors of human demonstrators, but also the thoughts humans have as they perform these behaviors. While we expect thought cloning to truly shine at scale on internet-sized datasets of humans thinking out loud while acting, e.g. online videos with transcripts, here we conduct experiments in a domain where the thinking and action data are synthetically generated. Results reveal that thought cloning learns much faster than behavioral cloning, and its performance advantage grows the further out of distribution test tasks are, highlighting its ability to better handle novel situations. Thought cloning also provides important benefits for AI safety and interpretability, and makes it easier to debug and improve AI. Because we can observe the agent's thoughts, we can, 1. More easily diagnose why things are going wrong, making it easier to fix the problem, 2. Steer the agent by correcting its thinking, or 3. Prevent it from doing unsafe things it plans to do. Overall, by training agents how to think as well as behave, thought cloning creates safer, more powerful agents. Modeling Human Behavior Part 1 Learning and Belief Approaches by Andrew Fuchs and Andrea Passarella and Marco Conti. There is a clear desire to model and comprehend human behavior. Trends in research covering this topic show a clear assumption that many view human reasoning as the presupposed standard in artificial reasoning. As such, topics such as game theory, theory of mind, machine learning, etc. all integrate concepts which are assumed components of human reasoning. These serve as techniques to attempt to both replicate and understand the behaviors of humans. In addition, next-generation autonomous and adaptive systems will largely include AI agents and humans working together as teams. To make this possible, autonomous agents will require the ability to embed practical models of human behavior, which allow them not only to replicate human models as a technique to learn, but to understand the actions of users and anticipate their behavior, so as to truly operate in symbiosis with them. The main objective of this paper is to provide a succinct yet systematic review of the most important approaches in 2 areas dealing with quantitative models of human behaviors. Specifically, we focus on I. Techniques which learn a model or policy of behavior through exploration and feedback, such as reinforcement learning, and 2. Directly model mechanisms of human reasoning, such as beliefs and bias, without going necessarily learning via trial and error. Credit assignment, challenges and opportunities in developing human-like AI agents by Trina Nguyen and Chase McDonald and Cleotilde Gonzalez. Temporal credit assignment is crucial for learning and skill development in natural and artificial intelligence. While computational methods like the TD approach in reinforcement learning have been proposed, it's unclear if they accurately represent how humans handle feedback delays. Cognitive models intend to represent the mental steps by which humans solve problems and perform a number of tasks, but limited research in cognitive science has addressed the credit assignment problem in humans and cognitive models. Our research uses a cognitive model based on a theory of decisions from experience, instance-based learning theory, IBLT, to test different credit assignment mechanisms in a goal-seeking navigation task with varying levels of decision complexity. Instance-based learning, IBL, models simulate the process of making sequential choices with different credit assignment mechanisms, including a new IBL-TD model that combines the IBL decision mechanism with the TD approach. We found that, 1. An IBL model that gives equal credit assignment to all decisions is able to match human performance better than other models, including IBL-TD and Q-learning. 2. IBL-TD and Q-learning models underperform compared to humans initially, but eventually, they outperform humans. 3. Humans are influenced by decision complexity, while models are not. Our study provides insights into the challenges of capturing human behavior and the potential opportunities to use these models in future AI systems to support human activities. A Machine with Short-Term, Episodic, and Semantic Memory Systems by Taewon Kim, Michael Cochet, Vincent Fran /C, O.S. Lavitt, Mark Nierinks, Peek Vossen. Inspired by the cognitive science theory of the explicit human memory systems, we have modeled an agent with short-term, episodic, and semantic memory systems, each of which is modeled with a knowledge graph. To evaluate this system and analyze the behavior of this agent, we designed and released our own reinforcement learning agent environment, the room, where an agent has to learn how to encode, store, and retrieve memories to maximize its return by answering questions. We show that our deep Q-learning-based agent successfully learns whether a short-term memory should be forgotten, or rather be stored in the episodic or semantic memory systems. Our experiments indicate that an agent with human-like memory systems can outperform an agent without this memory structure in the environment. COCO, CBT-based conversational counseling agent using memory specialized in cognitive distortions and dynamic prompt, by Suyin Lee, Jun Kong, Haram Kim, Hyungmi Chung, Dongga Lee, Jin Young Yo. The demand for conversational agents that provide mental health care is consistently increasing. In this work, we develop a psychological counseling agent, referred to as COCO, that applies cognitive behavioral therapy, CBT, techniques to identify and address cognitive distortions inherent in the client's statements. Specifically, we construct a memory system to efficiently manage information necessary for counseling while extracting high-level insights about the client from their utterances. Additionally, to ensure that the counseling agent generates appropriate responses, we introduce dynamic prompting to flexibly apply CBT techniques and facilitate the appropriate retrieval of information. We conducted dialogues between COCO and characters from character.ai, creating a dataset for evaluation. Then, we asked GPT to evaluate the constructed counseling dataset, and our model demonstrated a statistically significant difference from other models. Enabling AI and robotic coaches for physical rehabilitation therapy, iterative design and evaluation with therapists and post-stroke survivors by Min-Hun Lee, Daniel P. Siwirek, Asim Smilogic, Alexander Bernardino, Sergi Berm /Udez Ibadia. Artificial intelligence, AI, and robotic coaches promise the improved engagement of patients on rehabilitation exercises through social interaction. While previous work explored the potential of automatically monitoring exercises for AI and robotic coaches, the deployment of these systems remains a challenge. Previous work described the lack of involving stakeholders to design such functionalities as one of the major causes. In this paper, we present our efforts on eliciting the detailed design specifications on how AI and robotic coaches could interact with and guide patients' exercises in an effective and acceptable way with 4 therapists and 5 post-stroke survivors. Through iterative questionnaires and interviews, we found that both post-stroke survivors and therapists appreciated the potential benefits of AI and robotic coaches to achieve more systematic management and improve their self-efficacy and motivation on rehabilitation therapy. In addition, our evaluation sheds light on several practical concerns, e.g. a possible difficulty with the interaction for people with cognitive impairment, system failures, etc. We discuss the value of early involvement of stakeholders and interactive techniques that complement system failures, but also support a personalized therapy session for the better deployment of AI and robotic exercise coaches. From DDMs to DNNs, using process data and models of decision-making to improve human-AI interactions, by Mrugsen Nogsen Gopnarayan, John Aru, Sebastian Gluth. Over the past decades, cognitive neuroscientists and behavioral economists have recognized the value of describing the process of decision-making in detail and modeling the emergence of decisions over time. For example, the time it takes to decide can reveal more about an agent's true hidden preferences than only the decision itself. Similarly, data that track the ongoing decision process such as eye movements or neural recordings contain critical information that can be exploited, even if no decision is made. Here, we argue that artificial intelligence, AI, research would benefit from a stronger focus on insights about how decisions emerge over time and incorporate related process data to improve AI predictions in general and human-AI interactions in particular. First, we introduce a highly established computational framework that assumes decisions to emerge from the noisy accumulation of evidence, and we present related empirical work in psychology, neuroscience, and economics. Next, we discuss to what extent current approaches in multi-agent AI do or do not incorporate process data and models of decision-making. Finally, we outline how a more principled inclusion of the evidence accumulation framework into the training and use of AI can help to improve human-AI interactions in the future. What can speech and language tell us about the working alliance in psychotherapy? By Sebastian P. Beryl, Gabriel Roccabruna, Shamar Absar Chowdhury, Tommaso Cieli, Marina Danieli, Corbinian Reedhammer, Giuseppe Riccardi. We are interested in the problem of conversational analysis and its application to the health domain. Cognitive behavioral therapy is a structured approach in psychotherapy, allowing the therapist to help the patient to identify and modify the malicious thoughts, behavior, or actions. This cooperative effort can be evaluated using the Working Alliance Inventory Observer-rated shortened at 12 items inventory covering task, goal, and relationship which has a relevant influence on therapeutic outcomes. In this work, we investigate the relation between this alliance inventory and the spoken conversations, sessions, between the patient and the psychotherapist. We have delivered 8 weeks of e-therapy, collected their audio and video call sessions, and manually transcribed them. The spoken conversations have been annotated and evaluated with WAI ratings by professional therapists. We have investigated speech and language features and their association with WAI items. The feature types include turn dynamics, lexical entrainment, and conversational descriptors extracted from the speech and language signals. Our findings provide strong evidence that a subset of these features are strong indicators of working alliance. To the best of our knowledge, this is the first and a novel study to exploit speech and language for characterizing working alliance. Zero-shot goal-directed dialogue via RL on imagined conversations by Joey Hong and Sergey Levine and Anka Dragan. Large language models, LLMs, have emerged as powerful and general solutions to many natural language tasks. However, many of the most important applications of language generation are interactive, where an agent has to talk to a person to reach a desired outcome. For example, a teacher might try to understand their student's current comprehension level to tailor their instruction accordingly, and a travel agent might ask questions of their customer to understand their preferences in order to recommend activities they might enjoy. LLMs trained with supervised fine-tuning or single-step RL, as with standard RLHF, might struggle which tasks that require such goal-directed